All right, so we're going to be finishing up 8.2 here. It's saying in a random sample of 750 drivers, what is the probability that less than 728 of them will be speeding? And I already found that the proportion of that is 0.97066. And then I've got a picture here. And there's that proportion right there. So I'm going to copy and paste it into my notes here. Give us some picture of what's going on. All right, but that's a left tail probability, and Excel does a very good job with left tail probabilities. So this won't be hard to find at all. Left tail area for part D. It'll be equal to norm dist. Now remember, my computer does the dot thing. If yours doesn't, that's okay. That's just older school Excel. And it was, and I'm going to actually type in the fraction because I want to be more accurate. If I round to 9.7, that's not quite the same thing. So I'm going to do 728 divided by 750. The mean was 0.98. The standard deviation, I'm going to use this cell reference because it's a lot better than trying to type. Remember, when you type, you tend to round, and rounding isn't really good for these problems. You want to keep all your accuracy till the end. All right, so it's 0.0339. Oopsie, that's not what I meant to press. There it is. Probability equals 0.0339. Hold on. I just said it a second ago and I forgot. Yep, 0.0339. Cool. All right, so would finding less than 728 speeders be unusual? Yes, because the probability of that happening by accident is 0.0339, which is lower than 5%, our magic threshold for unusual in this class, more often than not. So suppose you did get a sample. What are some conclusions, a sample that was less than 728 speeders? What are some things that could happen? Okay, well, it could be a fluke, right? The chances of that is 0.0339. Okay, what else? What else could happen with catching speeders? Maybe the police weren't as covert as they thought they were, right? Maybe there were a lot of traffic accidents. Right? By not covert, I mean maybe people could see the car, spot the radar gun or whatever. Maybe people found out the cops were on patrol and so went slower. All these are the same thing. They're all falling into the same heading, which is biased sample. Maybe your sample was not as random as you thought it was. And if it's not, then all your data calculations from there get thrown off. Now there's one other option. So suppose you were covert. You know they didn't see you. You know that your sample was nice and random. And then suppose you just don't buy that it's a fluke because the chances of that are so low. So maybe possibly the true proportion of speeders is not 0.98 anymore. Maybe it was that, but now it's changed. Maybe people are conserving fuel more. I mean, you conserve fuel when you go a little bit slower. So maybe because they want to save money for gas or something. You don't know. But maybe the 98% that it used to be is no longer any good. And I reiterate from section 8.1, that sentence right there is exactly what you're doing in hypothesis testing in chapters 10, 11, and 12. You say, look, I know I got a random sample, and I think this is too low of a chance, so I think something else is going on. Namely, the data they gave me to begin with is wrong. All right, we are done with chapter 8. I hope you enjoyed it. I'll see you back here later for chapter 9.